All right, chapter 7, scatterplots, association, and correlation. So scatterplots are the best way to see relationships in data. Look for possible association. When examining a scatterplot, look at first direction, meaning is it negative or positive? Look at the shape. Is it linear? Is it curved? Is it random? Etc. And then look at the strength. So is it strong? Is it weak? Is it moderate? And mention outliers. So this is going to be another one of those where sometimes if we remove the outlier, it completely can change the association. So this one on the left, and then I'll pause for a second for y'all to get this after I write this, is a moderately strong, positive, linear relationship then the one on the right is, we need to add a couple dots probably to make it look, is going to be a weak, negative, curved relationship. It's like how tightly the dots are packed together.
Got it.
the variables that go on the x-axis are the independent or predictor variables. Then the response variable, or like the dependent variable, is the variable of interest. That goes on the y-axis. One page down. Next we have correlation, and this measures the strength of a linear association between two variables. It is a more specific definition in stats than the general meaning of correlation. So we have what we call the correlation coefficient. And you all should have seen this at some point with me before. But the correlation coefficient R gives a numeric value for the strength of the linear relationship it ranges from +1, which is a perfect positive relationship, to -1, which, shocker, is a perfect negative relationship. Can't talk. Perfect negative relationship. Then a correlation coefficient near 0 indicates a weak or no evidence of a linear association. Now, something to note about that part, though. This does not mean there is no relationship. Only no linear relationship. So we have some correlation conditions. Check the following. So first and foremost, we've got to have quantitative variables. So can't be categorical. 2, it's got to be a straight enough scatter plot. And that just means that the dots kind of need to generally be in like a line, not like a curve or, something crazy. And 3 is no outliers. So typically that just means removing the outlier point if there is one. Now, something to note, these are all checked. By examining the scatter plot. You can calculate the correlation coefficient for a set of data using the linreg command on a calculator. Grab your calculators out super fast because I want to make sure your calculator is set to give you that value. So when you turn it on, you're going to hit mode and then arrow up till you see stat diagnostics. So mode and then arrow up, stat diagnostics. And then it should be on. If your diagnostic is off, you need to turn it on.
I don't see stat diagnostics.
What do you see?
When I arrow up, it's only just math print classic.
Mine is 4th from the bottom.
Are you on math print? Okay, I found stat diagnostics. It's towards the bottom, so you said that should be on or on?
Yeah, it needs to be on. If it's not on, you won't get a correlation coefficient when you do linreg.
Okay.
So, just want to make sure that we have that.
My calculator thinks it's 2001.
Mine I think does too. Yep. It's January 1st, 2001. at 12:55 a.m.
Mine
September
says
12th,
it's
2001.
January 1st,
11:25 p.m.
2015.
January 2015 p. 22 a.m. Why is mine it's September 12th?
It's based on when you change the batteries in your calculator. Or I think if theirs completely dies, it resets.
Well,
I don't know.
changed my batteries in 2001.
But it automatically resets to that because that's when this calculator, I think, was invented. Or something like that. I don't really know. Couldn't tell you. I used to change it so it would be updated for like tests and stuff because we weren't allowed to turn around and look at the clock. So I would like make sure the time and stuff was right on it so I could do it. So I'm just going to make the little note here. Stat diagnostic needs to be on. Which it should always be on and forever now that you've turned it on, but you never know. Things happen. Other people use your calculator. Who knows? All right, so a few things just to note here.
Can you go back just for the correlation condition?
Have you written all this other stuff? Are you that far behind? Okay, well, wait.
I'm going as fast as I can.
You're good. We don't even have a full page left, so we're good. I'd rather you catch up because I'm about to write a lot, so.
Wait, you are?
Well, like, the next thing of, like, things that all goes together is,
Yeah, I already know what
it's like 6 points, but probably 7, maybe 8 lines.
Yeah.
You good? Okay. All right. The sign of a correlation indicates the direction of the association. So meaning like positive has a positive association. So think like positive slope. Negative would be a negative association. So negative slope kind of thing when you're looking at it. It's always between -1 and 1. and rarely exactly -1 or 1. Correlation is the same for x to y as y to x. It has no units. Variables can have a strong association but low correlation or correlation value. If the relationship isn't linear. And correlation is sensitive to outliers. All right, now you need to be aware that correlation is not equal to causation. We can only describe association by saying increased variable x is associated with increased or decreased variable y. Be aware of lurking variables. And so lurking variables are things that play a factor but aren't directly being looked at. All right, so an example of a good correlation statement. There appears to be a strong positive linear correlation between hours studied and test scores. Students who studied longer tend to have higher test scores. Now, here's the what not to do. Don't assume causation by saying something along the lines of, if a student studies for more hours, their test score will increase. That is all the notes for this chapter.